9 minutes. That is BYD's new answer to one of the biggest objections to electric cars, waiting for a battery to recharge. In March 2026, the Chinese automaker announced Blade Battery 2.0 and a new flash charger capable, under its stated Chinese market conditions, of taking a compatible battery from 10 to 97% in 9 minutes. 10 to 70% can take as little as 5 minutes. Those numbers sound less like ordinary charging and more like filling a fuel tank. But what has actually changed, and does this mean every electric car will soon charge in 9 minutes? The real story is more interesting than the headline. Start with the original Blade battery. BYD built it around lithium iron phosphate, or LFP, chemistry. LFP batteries generally trade some energy density for strong thermal stability, long cycle life, and the avoidance of nickel and cobalt in the cathode. BYD then changed how the cells fit inside the pack. Instead of placing many small cells inside separate modules, it used long, flat cells arranged tightly in a structural array. BYD says this raised pack space utilization by more than 50% compared with conventional module-based packs. That design became famous because of a dramatic nail penetration demonstration. A metal nail was driven through a charged cell to trigger an internal short circuit. BYD reported that its blade cell produced neither smoke nor flame and reached a surface temperature of roughly 30 to 60 degrees Celsius. That is a manufacturer demonstration, not proof that any battery is impossible to ignite, but it illustrates why thermally stable LFP chemistry attracted so much attention. The new problem was speed. Fast charging pushes large electrical currents through a battery. Resistance creates heat, and lithium ions must move quickly through the electrolyte and into the anode without causing damage. Increase charging power too aggressively, and the battery can overheat, degrade faster, or experience lithium plating. So a headline charging number is never just about building a larger charger. The battery, cable, cooling system, power electronics, and local electric grid all have to cooperate. BYD says Blade Battery 2.0 attacks resistance at several points. Its new cathode is engineered to release ions more quickly. Its electrolyte is optimized for higher ionic conductivity, and its anode gives lithium ions more pathways to enter the material. The company also describes a thinner, denser protective layer on the anode that is designed to combine conductivity with chemical stability. In plain English, BYD is trying to create a wider, smoother highway for ions. If ions move with less resistance, less energy turns into unwanted heat, and the battery can accept more power. Then comes the charger. BYD rates the Chinese market flash charger at up to 1500 kilowatts through a single connector. That peak figure is enormous. It is several times the maximum power offered by many existing public fast chargers, although peak power and average power are not the same thing. A battery rarely holds its maximum charging rate from start to finish. There is also a grid problem. A charging station drawing that much power can place a heavy load on local infrastructure. BYD's proposed solution pairs stations with energy storage. The storage battery fills more slowly, then releases energy quickly when a car needs a high-power charge. Think of it as a reservoir. The grid supplies a steady stream, while the reservoir delivers a short burst. BYD said that more than 4,200 flash charging stations were installed across China by March 2026, with a target of 20,000 by the end of the year. Overseas deployment has been promised, but timing and final specifications will vary. The first European model announced for the system is the Denza Z 9GT, and full regional details are still expected. So, should drivers believe the 9-minute claim? Believe it as a best-case manufacturer specification for compatible hardware, not as a universal promise. The result depends on starting charge, battery temperature, vehicle version, charger availability, and the way the charging curve falls as the battery fills. BYD also quotes more than 1,000 kilometers of range under China's CLTC test cycle, which is not directly comparable with American EPA or European WLTP figures. The safety claim deserves the same careful reading. BYD says Blade Battery 2.0 completed a simultaneous fast charging and nail penetration test without thermal runaway, smoke, or fire, even after 500 fast charging cycles. It also reports a forced short-circuit test involving 4 cells with no fire or explosion. These are impressive company-reported tests, but long-term independent results from vehicles in everyday service will matter more. Even with those caveats, the strategic importance is clear. Chinese manufacturers are no longer competing only on vehicle price. They are pushing battery chemistry, pack construction, charging equipment, and energy storage as one connected system. That vertical integration lets BYD redesign the entire charging experience rather than improving one component at a time. If the infrastructure scales and the batteries retain their health, the psychological gap between refueling and recharging could shrink dramatically. A driver may care less whether a car has 500 or 700 kilometers of range if a useful charge takes only a coffee stop. The 9-minute battery is not the end of range anxiety. It is a challenge to the rest of the industry. Charging speed is becoming a systems race, and China intends to lead it. Would 9-minute charging make you switch to an electric car, or would you wait for years of real-world battery data first?